Hi, everyone. My name is Bae Chung. I'm a PhD student at the University of Texas at Austin in the Department of Civil, Architectural, and Environmental Engineering. I am working as a graduate research assistant under Dr. Carlos Caldas, who is a professor here also at UT Austin in the Construction Engineering and Project Management program. For this conference, I would like to present our work on how blockchain-based implementation for risk management can be applied in healthcare construction projects. First, before diving into blockchains and risk management, we need to understand the unique characteristics of healthcare project and facility. What we refer by healthcare project is building or renovating facilities that provide medical services such as hospitals, clinics, patient care centers, and so on. These facilities offer a wide range of spaces from surgical rooms, laboratories, patient rooms, and many more. A lot of these facilities, especially hospitals, are open 24/7 throughout the year. And it is important to consider that patients are incapable of self-preservation. This requires unique building components such as backup power, extensive firewall, and alarm systems. In addition to complying with the typical building codes, hospitals have specialized codes for mechanical, electrical, and plumbing systems, also for safety and infection control, and more. Total construction spending in healthcare projects have been continuously increasing, which was close to $48 billion in 2020. So a lot of money is being spent on healthcare projects. And as these projects can be very complex, rigorous risk management should be made throughout project lifecycle to prevent any cost overruns. Let's look at what are some of actual risks that makes healthcare projects difficult. As you may know, hospitals are often located in crowded metropolitan areas. This makes the delivery of materials, heavy equipment, and workplace planning very difficult. Design coordination between multiple disciplines can be very complicated, as hospitals have complex MEP systems, and things can go wrong when planning between these systems go wrong. Hospitals frequently go through expansions, which means the construction must consider existing facility and operation. There is a wide range of clinical spaces as well, from simple exam rooms to operating rooms that may require medical equipment. All these risks, when not managed properly, could result in cost overruns, schedule delays, and quality problems in construction. Take this medical center in Colorado for an example. This 9-building medical complex was initially planned to be finished by 2013, and the agency estimated $537 million for the whole project cost. However, the final cost turned out to be around $1.7 billion, which was more than $1 billion over budget. The project also finished 5 years behind schedule. This example shows that risk events in construction should be taken seriously and managed for the project to be completed on time under the estimated cost. So how a typical risk management process is done is through 5 steps: identification, assessment, analysis, mitigation, and monitoring. Through these 5 steps, the project team can identify the risks present in a project. The risk events are then evaluated in terms of likelihood of occurrence and its relative impact in either cost or schedule. After analyzing probable outcome of risks, risk mitigation takes place to manage, eliminate, or reduce risk to an acceptable level. The team should monitor the status of the risk carefully so that proper measures can be taken at the right time. As multiple stakeholders have different objectives in a project, it is important to reflect the different views that they have on each risk and provide them a collaborative way to assess them. A conventional way of doing this is by holding a risk workshop where project stakeholders can share their thoughts on potential risks based on their knowledge and experience. Based on this group discussion, projects often use risk register, which is used to document the risk management process, like the figure on the right. Several studies have also developed web-based tools that facilitates the collaborative risk management. However, the problem with the current risk management processes is that they are centralized systems that require a trusted central authority to manage everything. Centralized systems having a single point of control may cause problems. One could be related to security, as transactions have the risk of being stopped and terminated if the controlling entity shuts down abruptly. Also, someone could maliciously try to tamper with the data. Blockchain technology can provide a decentralized system that can be trusted by the members of the team. By creating a peer-to-peer network, the central authority won't be controlling all the transactions. Users will interact with each other, where transactions will be appended to the blockchain through the form of blocks, and therefore, data will be stored in a more secure and tamper-proof manner. Along with this, a very important aspect is the use of smart contracts. Smart contracts are lines of code stored on a blockchain that run when predetermined conditions are met. In risk management, stakeholders often have sensitive information that they are unwilling to share with others. And smart contracts can be used to tackle the problem of data privacy. Smart contracts enable the users to preserve their confidential information, but aggregate and compute that information to benefit everyone. So as a part of exploring the applicability of blockchain, we conceived a conceptual risk management prototype, which will facilitate the risk management among stakeholders. This prototype will be a private permission blockchain where only verified users are allowed to access the network and publish blocks. Using an open source blockchain platform called Hyperledger Fabric, the project stakeholders are added to the risk management channel to provide their inputs on different risk events. The diagram on the left shows the flow of the conceptual prototype process. The process starts with the project owner creating a project entity on the blockchain, along with a brief description of the project. Description should include some basic project information, its cost and duration, which should be provided to the stakeholders. The next step in the process is soliciting input on potential risk events from the stakeholders. Each user who is a participant of the project should have been added to the blockchain channel to perform certain functions. Thus, the project creator will send requests to the stakeholders through the blockchain channel, and they should submit a list of risk events which they think might impact the overall cost of the project. The diagram on this slide shows an example of risk event solicitation. For the construction of a medical office building, user one in this case identified risks such as requests for additional medical gas outlets, delays due to installation of fire alarm systems, building requirements for safety and infection control. User two also provide their own set of risk events related to installation of medical equipment, change in design due to MEP system requirements, and change in design to expand clinical spaces and operating rooms. There could be many more risk events in healthcare construction, which will all be collected from the stakeholders at this stage. So different set of risk events have been collected from various users. In this step, the project creator validates the risk events that have been provided and compiles a single list of risks. Assuming that the users all provided risk events that are relevant to the project, there could be a certain amount of overlapping between these risk events if more than one user identified the same risk event. Therefore, the project creator should keep in mind that when creating a single list and then distribute this list back to the users through the blockchain. Users, when receiving the completed list, should understand the influence of each risk event to make proper risk assessment in the next step. Now, the users will assess the risk events by providing their likelihood of occurrence and the relative impact of the risk on project cost. As you can see in this example below, the likelihood is given by a percentage of how likely certain risk event might happen. The relative impact is also given by a percentage, how much cost should increase compared to the initial cost of the project without any risk event happening. The impact can be evaluated by a single estimate or a 3-point estimate, in this case, which are the minimum, most likely, and maximum impact that the risk event would have on the cost. So if we look at the first risk event, for instance, the user evaluated that there is 5% of the risk occurring. The relative impact on the initial project cost will be 3% at its minimum, 5% at most likely, and 7% at maximum. And while our prototype focused on the impact on project cost, it can also be applicable for finding the impact on project schedule. It just all depends on what is the main focus and interest of the project team. An important thing about the prototype is that the user's risk assessment inputs can be stored in a private state through the use of smart contracts. Often, these risk assessments are closely related to the objective of the stakeholder who is providing that input. Hence, the stakeholder might want to keep that information private. Smart contract can define the inputs to be only accessible by the user who entered that data, which means other users, even the project creator, cannot view what was the risk assessment given by that user. While the risk assessments are kept at a private state, smart contracts will utilize aggregation methods to generate the combined numbers and publish these on the blockchain. The aggregation methods used can be as simple as averaging the risk assessment inputs to using opinion polling methods. The combined numbers will not reveal the individual inputs, which protects the confidentiality of the data. And using the combined numbers, users can run risk analysis such as Monte Carlo simulation off-chain and use the analysis output to help make better project decisions. Lastly, blockchain technology enables monitoring and tracking of risk events. Risk assessment is not a one-time process. Multiple risk assessments should be made over the project lifecycle. And in a blockchain network, blocks are added in a chronological order. Each block contains a header which references the previous block and the transaction data that have been stored. Therefore, the fact that all the transaction history is kept on the blockchain network helps the stakeholders to see how the assessment has changed over time in the project. Finally, to summarize everything in this presentation, we first introduced some of the background on healthcare construction projects. As I mentioned, healthcare projects have some very unique characteristics, and there may be specific risks associated with them that are difficult to find in other types of construction projects. So the focus was placed on how to improve the risk management process for these healthcare projects. We talked about how things are conventionally done in the construction industry. One of the problems we discovered was that information sharing between multiple parties are done in a centralized manner, which could lay several issues related to security, trust, and reliability. Moreover, the bigger problem was preserving the confidentiality of risk information, as stakeholders want to keep their sensitive information to themselves. The way to tackle these problems was to develop a blockchain-based implementation and utilize smart contracts to keep the risk inputs private while using them at an aggregate level for risk management. Therefore, we conceived a conceptual prototype process that enables collaborative risk management. This process will bring huge benefit in utilizing private information for risk management and in tracking and monitoring risk events over time. The entire process of the prototype was explained in the domain of healthcare facility construction, but we believe it's something that can be applicable to any other problems that involve preserving confidentiality, such as patient care systems. Based on the presented work, we hope to have a working prototype developed so that we can pilot test it on an actual healthcare project and eventually validate the use of the blockchain prototype in risk management. That is the end of my presentation. I would like to thank my advisor, Dr. Carlos Caldas, for his guidance. and the researchers in the Operating System 2.0 Industrial Affiliates Program for providing a lot of help in conducting this research. Thank you very much for listening.